All right, Mac 132, Blueprint Reading 2. What did we learn today? Well, I handed out the test. There were 2 drawings on the test, and it was applied GD&T. Yeah, I think that we're going to have to put a curve on this test. It was a pretty difficult test because it called for a lot of application. In other words, you don't just remember and memorize facts and information and then put them on the test. You remember things that you learned and apply them to new situations in blueprint reading. So how do you get better at this? You do it repeated times. And realize also that just because you have an aha moment and all of a sudden you understand perpendicularity is tied to a position tolerance on a hole, that doesn't mean that you got it down yet. A week from now we'll throw a print at you and you'll completely have forgotten all of that unless you get your reps. You don't get strong in a gym just by going one time. You got to get repeated times on it. So now we move into more in-depth GD&T in chapter 14. We're going to talk a lot more about positional tolerances, and that's what we kind of did today. One of the problems on the test was the location of a hole had a 14 thousandths tolerance zone on it, and the question said when this hole is at a given size, what is the positional tolerance on it when it is that size? On the test, the answer was 23 thousandths because this hole, and this is a hole going through the part, as it gets bigger, the positional tolerance diameter gets bigger. It's 14 thousandths at maximum material condition, which means the smallest the hole can be, it's got a 14 thousandths diameter. As the hole grows out to 0.206, you got up to 24 thousandths total size of the tolerance zone that the hole's center or center axis locating can be in. Inside a 14 thousandths diameter circle, or out at 206, a 24 thousandths diameter circle, and the hole will still line up with the fastener. This is the table I used to show that, and that was on the test as well. We're going to go a lot more into detail on this, and so I wanted to show you the old ways of positioning. Used to be in X and Y, and it would say you had plus or minus 5 or 10 thousandths on the true position of the hole without geometric dimensioning and tolerancing on it. So they found that when they did this, that if this were 10 thousandths and this were 10 thousandths, that was 14 thousandths across here. So if we had plus or minus 5, technically we could be 7 thousandths out off of the center here, and they would say that was a bad part, even though it would function. So to settle the argument, they went to a 7 thousandths diameter circle, and you'll still be good here, but you'll also be good in these new bonus areas. 53% more surface area when we go to a circular tolerance zone for the position. So I asked you also to review and do the homework on page 329. Do it several times. And if you want, move on to the next page, which is page 331, and do it again. Another thing I handed out, and I'd like you to study, is this NIMS drawing that has all kinds of GD&T on it. And this will be a part that you're going to make about less than a year from now. This fall, this late fall, you're going to have to make this step block, we call it. And it's going to have a lot of positional tolerancing on the hole locations and on perpendicularity, parallelism, you name it. So thank you for your efforts today. I think that you can get an idea going forward if you want to do better. What you have to do as far as homework and repetitions in this course. Thank you. We'll see you Wednesday.